Okay, all right. So a very good noon to everyone. What we had done earlier, and now we will have to understand things in a bit more deeper way. That is, how we need to fit our application to basically how we'll have to fit our application so that it should fit our requirement. So what we have seen till now that we have been fine tuning the models. Just give me a second. What we have been doing till now, we have been actually fine tuning our models, right? Fine tuning our models. In fine tuning, what we have seen, in fine tuning, we have seen that, we did see using trainer API. Trainer API, what we did was we did a full fine tuning where all of the weights were updated. Then we went for basically LoRa, right? And then we went for quantized fine tuning, QLoRA, right? Now, we were trying to fine tune one model on QLoRA. It was taking too much amount of time. So what I have done is I have prepared a very small data set. We'll just have a look at it at a very small data set, right? On which we can simply fine tune it. And it's very easy. I mean, it will take some 5-7 minutes or so. Simple. Now, this is what we have been discussing till now on text models. What we tried with is we tried with Gemma 3, Gemma 3B. We tried with, I guess, GPT models. Today we'll play along mostly Quen 0.5 models. Quen 0.5. We'll play along with this, right? So also one thing that I want to tell you is that, for fine tuning, it is not important that always you go through all of these things. There are various platforms also available. One I have been using is Llama Factory earlier. So you can just go to Llama Factory, and what Llama Factory does is it will just give you, this kind of control panel. You will have to install it once in your system or server wherever you wish to, and all of the parameters you will get here. So it will simply tell you, what you have to install, what kind of fine tuning you want to do. But the only thing you will have to do, you will have to upload your data set in JSON format. You don't have to pay anything to anyone for this. You just have to update your data set in the JSON format. You can go ahead and you can just run it, and it will keep on running. If it is a long training, it will keep on running for few hours. If it is a short training, it will keep on running for few minutes or whatever is the, depending. And it supports lot of models. It supports all of the models: Quen, Llama 3, Mistral, Gemma, Llama 4. So everything that we require is already there, and these are the list of models it supports, right? Industrial grade open source application. Like, although we had to learn what is going inside, but yes, I mean, there are a lot of this is one of the finest application, wherein there are some paid websites also, or paid apps online that will host it for you, so you don't have to worry about GPU or anything. You can just go ahead. Now will have to research about those websites, because till now what we I have mostly been doing is I wanted to own my AI in most of the cases. But this is not the case always. Like I said, I mean, it is not important that always you go ahead and you'll have to fine tune your model and so on. But this is one of the finest library that have been tried and tested for, at least I have been using for 2.5 years, and I have prepared many good models from it, right? And it supports all of these things: PEFT, TRL, QLoRA, right? Fast chat is again one more format it has started supporting. There is one more type of fine tuning that we will see during are, when we'll start discussing about the RAG architecture, that is RLHF fine tuning, reinforcement learning. That is not fine tuning, but that is model alignment. Model alignment in the sense that sometimes we want, a model usually outputs various answers, option one, option two, option three. So we just want, out of these option one, option two, option three, I prefer this one for this answer, or for another answer I will prepare this option two. So basically it is basically alignment model, preference alignment that we have to do. And there are various other, I mean how the response, which response should the model prefer. So these kind of model alignments thing we will have a look later, in when we are when we'll start struggling with our RAG architecture. But for now, what we'll do is we'll see a small example of QLoRA, a very small example. Now, what I have done is, so that we do not waste a lot of time. I mean, we have already discussed. I won't write the whole QLoRA program. We'll just, I have already prepared the program. So we'll just go ahead and fine tune the thing. And I have also created, the data set this time. So then after that, basically the next thing that we want is we want something called as RAG architecture, right? We will be discussing about the RAG architecture. We'll have few sessions on this RAG architecture, right? When we are discussing RAG, we will also discuss how to query images also, not just text. We'll also see, but that comes under, as of now, what we are discussing text LLMs, right? Text LLMs only. So then we will go towards multimodal LLMs. So fine tuning multimodal LLMs is same almost, just with a small difference. So there itself we'll discuss a small example of how to fine tune multimodal LLMs, right? Fine tune multimodal. And these concepts are very easy, As of now, I will not use any framework, right? I will do it using pure Python, right? Then, I mean, it's choice most of the time. Then we can start using LangChain, right? And then basically from LangChain itself, we can start preparing the agents and all those things. We can start preparing those agents and MCP. So this is what next our course will look like, and this is what, once we have this MCP and once we have done all of these things, then there are some pending topics, like some theoretical topics we'll have to cover. Like we'll have to look at choosing the right loss functions and all of those things. Although we have prepared the loss functions, but we'll have to discuss more on it. I mean, this is just for optimization. I mean, loss function optimization, and this will be like, we'll be covering a lot of theory here in agents and LangChain, then prompt engineering, React prompts, and all of those things. I mean, although I have written it in a small way, but there is a lot of examples to be covered here. Then agents, lot of different type of agents, and how our agents can see and see the screen and identify that what kind of screen is this and all of those things. So we'll cover all of those exciting examples in this area. But first we'll have to let's quickly go ahead and start with that example, and then we will. So I will use Quen 0.5 model, very small model, and Quen 0.5 will also be a good model. For a few examples, we will use OpenAI, right? For those OpenAI keys, I will provide you. I mean, till this course is there, I will uh, make sure that those keys will be alive, right? Okay, we have this exercise 16, right? Although first and foremost thing for any kind of experimentation and everything, uh, we will use these open source models only, Quen, or there are a lot of different things. So, and then for when we have to go for production or anything, then we can go with production with these models also. There is no such problem. But there is a disadvantage that you have to manage a lot of infrastructure, and that becomes an overhead. So if your team is small, and basically you don't want to have a lot of members, one person dedicatedly for like deploying and all of those things, then you can have a very lean application that can directly use ChatGPT or Gemini or Claude or whatever it is, right? So, right. So we'll first see how do we want to fine tune our fine tuning QLoRA model. We'll just go with Quen 0.5, right? So I'll update or I have the program in my local. Just give me a second. So I am taking a very small example wherein I want that, I will write anything. I'll just show you the data set. We upload the data set and right. So basically my data set is pretty simple. I have created this myself. So what I did is, for 200 data sets, I am taking that my input expression should be like, input expression is 12 divided by 70. So 12 divided by, it should convert it into mathematical operation, right? So this is what I'm basically trying to fine tune it. Now I will use very small model Quen 0.5. Now I did not write the whole program, so I guess we'll have to quickly write our program here. Never mind. Let's quickly do it. First, I will have to pip install TRL is equal to 0.12.0. Mm, mm, mm. We do it myself maybe. Okay. From transformers import tokens. Nicer. Auto model for casual LM and then what else? That's it. Okay, let it install. Okay, we have it. Bits and bytes. Quen 2 0.5. It is from China, Alibaba. Right. Very small, 500 million parameters only. Right. And we'll just train it for training. So if we are defining these parameters properly, it becomes easy for AI to generate the program, right? So we can just, it will just, okay, read dataset in JSON format and fine tune and load model with bits and bytes. I guess we'll have to just write this part. For bits and bytes, it's fine. For auto model casual LLM, that is fine. Then tokenizer is also fine. LoRa config is also fine. Training arguments, right? So we'll just have to go through this. Training arguments is fine. LoRa config and safety trainer, everything is fine, I guess. Training arguments, we do not need so many training arguments. We'll just reduce it. LoRa config, dropout, bias is none, casual LM 0.1, right? Model, get preft model, correct. SFT trainer, trainer.save, everything is fine. We will just have to take care of our data set. Train, validate math expression, dataset.map and output JSON data files. Sorry, example and return. I guess this should be fine. Example of input, but we already have this thing, evaluate math expression. This will unnecessarily increase the prompt. I'll just remove this, and result, I guess we have this also, example underscore output. Text is here, and we have output expression. I guess we have the complete prompt here. And let me read the dataset myself. Load dataset, JSON format, right? Um, Dataset is equal to dataset, the JSON train. I, that's it. Dataset underscore I will get the training format, and that's it, I guess. Now dataset of zero text formatted dataset is not required anymore. Dataset is casual LM. Yeah, we are done. And in SF trainer, we can directly, yeah, instead of this, we can directly give dataset here. Report to none. Training arguments. Optimizer. This is an optimizer it has added by default. We can use it as of now. It's not harming us, but we'll have to discuss it. I mean, what is the use of all of these things? Logging learning rate with decay, FP16. Okay, I guess this is fine. It should give me an error as of now because we are using a brain float 16. So we'll have to switch to GPU for training. But there is some other error, I guess. Quen 0.5 model name. Quen 2 0.5. Let's just see that how it is performing. Mhm. The repo ID must be alphanumeric. From pre-trained device map auto. Okay. The model loaded. So let me try with this. Pre- Prepare the model k-bit training. No, this is not required. Auto tokenizer model loaded, pre-trained. Okay, BNB config. That is fine. BNB config. Load 16. Double quant. Okay. So what we'll have to do, so bits and bytes is not optimized for, okay, we are already on the GPU. All right. Okay. Dataset train import dataset JSON. Dataset file name map expression. I hope my model name is correct. Quen slash Quen 0.5 instruct. It seems to be correct. 6.5 instruct. Okay, this time it is taking some 3 minutes only. Let it complete. Code for testing model, testing the theft model we have trained. Theft, it is to get theft from theft model trainer. Where is my theft model part? Theft underscore model. And saved in model directory. Load from there. And okay, training has finished. The loss is not very great. I should run over maybe a few more epochs idly, but I mean, the training has finished. Let me check if it is fine or not. Where is it loading my model? I don't see it loading my model anywhere. Base model, pre-trained output dir, from pre-trained model ID, BNB config base model. Okay, model. This will be my model from here, right? This model. Okay, where is my output dir? Okay, I guess yes. Okay, so this was not my data set. Yeah, this is garbage. So let me run it on my data set. Let's say I will give, let me try first with this, then we'll give our own. So I'll just take, okay. Input expression 11 times 18. Input output generated response. No, it is not working even now. I guess we'll have to train it over. Let me try to retrain it once again. I mean, training epochs, I guess we have not trained it enough. Training arguments, learning steps, tokenizer, learning rate, batch size, and then number of training epoch. We have taken a training epoch of 5. Yeah, that is fine. This should work. I'll try it once again from instruction input. Okay, so into standard mathematical using standard symbols and digits, and input is convert 11 times 18 into maths expression. Okay, this time it has multiplied also 11 into 18. But the problem is that it is able to solve, but we'll have to fine tune it more if we want that, we would like to get our answers like in application, you want the answer to be very specific. We'll see that in RAG also. You want your answer that, my expression should be, let's say, in JSON formatted JSON, and it should say response, and response it should say expression, whatever 18 comma 11. That's it. So we need to then extract this the answer and display it to user. We'll have to display it to user. So yes, I mean, we were able to fine tune, not that good actually. So we'll have to fine tune it even more. We can try it on maybe 10 epochs or something like that, or maybe we can try with a different batch size, or so all of these things we can try. Now, this was a very small example of how you can basically train all of these models, using PEFT. So we have already discussed about PEFT, that what is PEFT, that is parameter efficient fine tuning. We have already seen this concept, that okay, parameter efficient fine tuning. But now the whole point is that we have fine tuned our models, but where, when and where do we need to fine tune our models, right? So one of the biggest application of AI that has come nowadays is RAG, that is retrieval augmented generation, right? Retrieval augmented generation. Now, why do we need this RAG thing? Why our model is not self-sufficient? So, see, now let's say I have my company information. I'll take a use case that what I want is, right? I want my AI bot to, you know, answer me from I have my company information. I have my company information. My company information, such as, when my company was incorporated, and then what products do I sell? What are the products do I sell? Right? The details about each and every product, details of each product, right? And then after detailing, basically, we have things like, that after detailing, we might have information like if any discounts are available or not. So what is my aim? I want to create a sales bot for my website, let's say sales bot, right, for my website. So I want to provide a discount, right? And if user is not getting convinced, I want to provide a discount. So it is my sales bot. It should have information about my company, my products, even my culture, right? And some of frequently asked questions, right? Frequently asked questions. It should have this information about me. Now, uh, one option is I can go ahead and I can fine tune my model. I can use a PEF and I can fine tune it, right? But yeah, I mean, since my data is small, I might survive this thing. I mean, it may be able to, but again, this information using PEFT will not be added. Like we have already discussed that using PEFT, we cannot add a new information. We cannot add new information, right? Then second option is you can go for full fine tuning, full fine tuning. But any model, if you go for full fine tuning, till the time you are not ready to invest too much time, in less amount of time, this can be risky because full fine tuning, it has to be a very uh, calculative job, in the sense it has to be a very fine balancing act, because when you train some data, it will forget some data, it will forget some data, right? If you are fine that okay, if your decision is fine that okay, my model just needs to remember this information, and I will give various kinds of data set on this information only, and this model needs to just remember this, then it is fine, right? Then it's okay. But again, even in that case, you have to make sure that at least these small models, they don't forget how to even write proper English or whatever language you are training on. So you have to be very careful. Like I said, it has to be a balancing act. So how do you balance? You balance using evaluators. Evaluators. We'll just discuss on them. But evaluators are nothing, just a data set on which basically you keep on testing that after training how much has this performed on this data set, after training how much has this performed on other data sets. So you keep on comparing and doing on those evaluation data sets, right? You keep on doing that activity. Again, like I said, full fine tuning is a very tedious job. I mean, it's not an easy job until unless you're not very much confident that okay, I might have to do it, and then this is only the information it needs to remember, then that is fine. However, one important point is, I mean, it doesn't happen that you fine tune the model once and it runs perfectly. It does not happen. It will never happen. In fact, you'll have to fine tune the model on various parameters, and then you will have to keep on adding those information. Maybe you can use any experimentation tool for that. Let's say you can have that. Okay, my model one was trained on some strategy one. My model one was trained using some strategy one, parameters, different batch size, all of these things, batch size or different embeddings also, whatever the different things. And then this is the result I have. Right? So there are various, like we have few various applications that are free and open source, which we can use instead of documenting on some document or something like that. So it becomes easier. And this is the daily life of an AI engineer. This used to be earlier. Now it has changed. This used to be, and even in some companies that are actually creating technology from scratch, this is what is the life of an AI engineer. AI engineer will keep on using the data sets. He will keep on adding new architectures and new hyperparameters, and he will keep on accumulating those results, right? And then after a while, we have all of our experimentation done. Then we can have a look that okay, this is what is the best model. Let me retrain it full fledged on this model, and then I will go ahead and deploy it. Right. So, like I said, but again, in normal industry, what is happening? Fine tuning these full fine tuning these big models is not an easy job. It is a costly job, and also sometimes, what has started happening that what has started happening that these uh, people want that it should remember huge information, that you have a model, right? And it should remember some 10,000 documents. In the sense, it should have knowledge of these 10,000 documents, right? It should have knowledge on these 10,000 documents. A very famous use case of contract repository that many companies have not been able to crack till now, right? And the reason is, now it is not that, look, this contract repository on 10,000 documents, I'll build it in next 15 minutes. But it's all about accuracy, right? So good accuracy, I mean, there are multiple companies that have released, and there are a few companies that are trying to come up with all of these things. But the whole point is accuracy. How accurate the thing has to be. In the sense, contract repository, that let's say there are some 20,000, 30,000 contracts of an organization, and I just go ahead and I ask that, am I like compliant with XYZ thing, or am I supposed to take my data outside European Union? What is GDPR compliance, and how many contracts are preventing me from GDPR compliance? How many contracts are preventing from GDPR compliance? So these kind of simple queries I should be able to fire, and it should go ahead and scan through these 20,000 documents or 10,000 documents and give me the right response. Right? It should be able to give me the right response. So this is the challenge that what RAG is addressing. Now again, I said RAG, running a RAG is just like 1 day job, but find getting accuracy from RAG is a complex job. I mean, it doesn't get so easy, right? So first, let's have a look at it, that what basic RAG is, right? RAG, we have a pipeline now. We have started using these pipelines that, like I said, first we will have some huge amount of documents. For now, let's say, we'll start with 10 documents only, right? We'll start with 10 documents. Right? Let's say 10 PDF files, 10 PDF files. And these 10 PDF files, what I'm going to do is I will be reading these 10 read into text, and then I will be dividing these. I mean, to see, there is no point in uh, let's say I have one PDF file of 30 pages. There is no point I read the whole PDF file. I need some strategy so that I can retrieve this data at any point of time, so that I can retrieve this data. So then what happens, basically, you chunk the data. Chunk the data. What is chunking in plain English? dividing into small logical texts. Now this is very important. Dividing into text is one thing, into small logical text is one other thing. This this means that, let's say I have a PDF and I should be able to divide that document into such a way similar text remains at one place, right? All of the similar text, it should come at one place, or and all of the non-similar text or whatever is there, it should be stored properly into my vector database, right? So I need to chunk this PDF file. Let's say I have 10 PDF file, one PDF file. I can decide my chunk. Smaller the chunk, better the accuracy, but it will take more time. Smaller the chunk, right? Smaller the chunk, it will have more accuracy. But with accuracy, if accuracy is increasing, time will decrease. So again, this becomes a balancing act here. What we need, we'll have to come to a point wherein with the given hardware, we have fine accuracy as well as the time is less. Right. So as of now, we will chunk it normally. I mean, as we see, but yes, I mean, we will see in future various libraries like, Dockling, etc., wherein, let's say, if we want to uh, have complex documents, tables, figures, documents are not that simple. Documents can have tables, documents can have figures, images, and those images can have some meaning, right? So, I mean, getting a true RAG to work is really a lot of hard work, a lot of, these jobs we need to do, that so that the data is clean, data is understandable, and all of those things, right? Now, so this part is called as chunking, right? So we'll have to do the chunking part. And after chunking is done, next part, we have chunked the data that is into smaller regions. Then we go ahead and we store this into vector database. We'll go ahead and store it into vector DB, right? Okay, this is part one of storing. This is storing. Now, again, storing is not this simple also. For normal applications, obviously you can follow this path, but there might be chance that when the documents are very complex, let's say service level agreements, just for everyone's reference, are those agreements, wherein they have lot of conditions, that if this happens, then this is the fine. If this happens, then this is the charge. If this milestone is complete, then this happens. So these kind of things are complex. They have data in tables, and those tables can have rows up to 100, even 200, 300 rows, right? So all of these things, it becomes very complex. Simpler the document, simpler the life is, right? So, right. So we will have to, use various techniques to simplify this data, and we'll have to see that how we are going to simplify this data so that it can be easily, understood by this vector DB. Now, this vector DB, okay, this is one part, storing part. Vector DB is available at various places, right? You can go ahead and you can use various vector DBs, such as you can go ahead and you can use vector DB from, as of now, we will use from our local system only, right? We will use like FastDB as of now. This is a lightweight one. This is very lightweight for our POCs. For good ones, you can go ahead and use VWeight. This is a production grade. You can go ahead and use. Then if you do not want, again, like I said, even sometimes maintaining this is also a overhead, because when your data is huge, you do not want to risk it all, security compliances and all of those XYZ 24/7 uptime and all of those things. You can go ahead and you can have small. Now I think even MongoDB has started providing this a vector DB, but I am not sure about it. MongoDB is like, hosted database it provides. If you do not want to purchase it through Azure or AWS or anything, you can just go ahead with MongoDB. Right. So then you can obviously go with, AWS. You can go with AWS, or, you have uh, then Google Cloud, you have Microsoft Azure, and these are just of the some big names. We can go ahead with lot of others like Snowflake, etc. Right. Lot of good database providers are present. It really depends on your budget, right? But like, I mean, my job is to give you the zero budget solution. So you can go ahead with any of these things. ChromaDB is also the free one. ChromaDB is also free. See, until and unless you're not on very enterprise grade, you're not, if you're dealing with enterprise grade application, go ahead, tell them that, you need it from AWS or Google Cloud. You will need an enterprise vector DB there. But yeah, I mean, if you're building your own applications, these will be more than enough. I mean, it is not that these are these cannot handle huge amount of documents. These can handle pretty huge amount of documents for you, right? Okay, so this is about the vector database. Now, after vector database, now comes the bigger part. That is, the story is, how do you want to fetch the data? We have, my data is, let's say you have been able to build the vector DB in a optimized format, which is again a tough job. Having said that, I mean, does it requires a lot of, so basically see, these all things you will have to uh, do a lot of experimentation, that with your data, what is the accuracy of retrieval it is getting, we will see how to do that. It is a laborious job. Like I said, I mean, the data labeling part and all of those things, it is very laborious, and it requires huge amount of patience for you to test. You will have to be very patient in testing that, okay, what it is performing, what it is not performing. Now, this is, let's say, my vector DB. This is my vector DB, right? From my vector DB, now what I need is, I cannot go, my LLM cannot go and directly, so see, my LLM has a fixed context, right? Such as my Quen, I guess it has 2048 tokens, right? It has these many tokens. Then uh, even if I'm keeping it local, right? In local, let's say if I keeping it my local, let's say local machine or somewhere, then I don't have to worry about the money, right? So 2048 or 40,000 tokens, right? Or if I go for DeepSeek or Llama, then I might have 16,000 tokens or something. But again, like, I have a limited thing. I cannot load 10-20 documents all together in one prompt, right? I will have limited prompt. So then it cannot interact, vector DB cannot interact with LLM directly. So now comes one more algorithm or program in between, right? There is one more program in between, and this program is responsible for, now let's say your query is where are we learning, where are we learning applied AI. Now this is not known to Google, this is not known to AI, right? But let's say it is present somewhere in the document here, right? Out of multiple documents. These are documents. One chunk is a document, right? We have divided the document into multiple parts, right? But each of one is a document, right? For us, it is a document. We can call it a document or a context, whatever you wish to call. I mean, one document. So the first part is that, uh, what we'll have to do, that let's say this is my query. I'll have to take this query vector DB only stores vector, right? It does not stores text. So step one, you will have to convert it into text embeddings. You will have to convert it into text embeddings. Now, when you convert this into text embeddings, right? These are also text embeddings. Then there is a algorithm that is automatically provided as of now using, you know, cosine similarity. I'll just talk about cosine similarity. Why it is a cosine similarity? Because, you know, everything is plotted in these 3D or n-dimensional graph. So let's say one document has vector here. It is having, so by definition, you know, another one similar, the most similar one should be present near to each other. This we did study during embeddings. The most similar one should be present near to each other, right? Again, we don't have to train it this time. There are some standard uh, good embeddings that are available, right, that we can use. Free ones are available, paid ones are also available. OpenAI, Gemini, Claude, all of them are selling their embeddings, right? You want to use their embeddings, you can use them. You want to use our embeddings, you can use, I mean, open source, you can use open source, right? So the whole point is, you know, what the simplest form of comparing is the distance between these two coordinates or vectors, v1 vector and v2. The distance between these two we measure using this, and this is called as cosine similarity. We call this as cosine similarity, right? And basically, so here cosine similarity is matching of two vectors, right? Using cosine similarity, it will find that okay, these three, let's say, it will find out that okay, one document one, D1, D2, and D3, that okay, D1, D2, and D3 are the closest to your query. These are, they might contain the answer to your query. Then you provide these to your LLM. You provide these to your LLM, and then your LLM provides you with a final answer. Final answer. So now what you have done is you have very cleverly, you have added external information to your model, right? Where are we learning applied AI? It does not, it did not knew this. But what we have done, we have prepared a pipeline using which any amount of external information can now be roped into your model. And thus, what we start having is, let's say, a good RAG system is very precious. It takes a good amount of time to build a good RAG system. Even today, people are struggling to build good RAG system. I mean, I did put my first RAG system on production in 2021, and I was one of the first movers into the RAG system. I mean, into the market. Basically, we were the first one to launch this. I read the papers, and I mean, I implemented those papers. Back in then, RAG was not even known to anyone. There were no frameworks like LangChain, etc. Nothing. I built everything from my own. And sometimes you are so advanced in the tech that even your company is not able to tell to your customer that you know what this is. Unfortunately, we had, I mean, in 2000, then in 2024, basically after 3 years, I kept on explaining that beauty of this system. They, when they heard outside that uh, RAG is something, then they started telling customer, okay, we also have RAG. See, we also have all of these things. So yeah, so my experience, our experience with RAG is very, very old. I mean, I have been building RAG, this application, and even today, if you go ahead and if you tell that on 30,000 documents, the accuracy of RAG, we were able to mint an accuracy of 94%. Uh, I mean, it is even today with all of the tools available, it is dead difficult on this amount of data set to on this amount of data to get this high accuracy. There were no LLMs, nothing, but still we were able to, uh, get that kind of accuracy. But obviously, there was a team that had to do a hell lot of testing. I mean, testing took around 4 to 5 months for each and every release. I mean, we were just doing 2 releases in a year, and a huge amount of effort used to go. So yeah, so the whole point being, yes, getting a good RAG system is costly. I mean, even if you sell it to customers will love it because it adds a lot of value to them. And but building this also is not that easy. Many a times, uh, you know, uh, you will have to do a lot of maybe fine tuning of the model, or you will have to introduce multiple models in between, right? So that any false positives, any biasness, because nowadays there are a lot of checks that it should answer should not be biased. It should be like not biased towards any gender, any ethnicity or anything like that, right? It should not be like racist and all of those things, although some of the checks are already present in LLMs. But again, if it goes from your system, then you are in the trouble, right? Yeah, so all of these things, having said that, right? So let's try to build one very simple RAG now, right? Let's try to build one very simple RAG on. What we'll try to do is we'll build using I mean, like I said, we'll build not use LangChain as of now. Again, what will be my flow? My flow is going to be simple, you know. So I will have is, first and foremost thing, I will have my text source here, right? This will be my document. I will have my document here, right? This is my document. And from my document, then I will have one, first and foremost thing is chunking. First, we'll have a chunking, right? Once we have our chunking, then what happens? This document will get divided into smaller parts. It is into smaller parts. Once it is into smaller parts, next, I would like to vectorize these documents, convert it into vectors. So convert into vectors. Once we convert them into vectors, what we'll do is we'll store them into vector DB, a vector database, a vector database, right? Then after that, what we need is, again, we will take a query from a user, or from a user. I mean, it depends on the architecture of your application. This is your query, but before it has to be converted into vector. So using sentence transformer, a library, we will convert it into vector, send query vector, vector q. And then from the vector and query, we will do cosine matching. We will do is cosine matching, right? And then in the result, it will give me most matching. Just give me a minute. Oh no. Okay. All right. Cosine matching, you know, cosine matching, it will give me most relevant or most matched documents, most relevant documents. And then let's have most relevant documents R1, R2, R3. You will feed them into any choice of large language model of yours. any LLM, it doesn't matters. LLM, right? R1 plus R2 plus R3, R1 plus R2 plus R3, and finally you have is you get your answer, right? So this is how the whole flow works. So now let's try to do one thing. Let's try to implement this, right? Let's try to implement this whole uh, cycle, and we'll see that how is it working. Just give me a break of 2 minutes. I'll just take a water break, right? And I'll be just back. Okay. All right. Let's now start building one. We have our small discussion. First, we'll see a small toy example, right?
So,
Uh, yeah,
Anand,
yeah.
so uh, the vector database, right? If we wanted to use, then what are that? In that case, we have to use the Azure AI services or
No, no, no,
AWS.
no, nothing.
Whatever you just explained earlier, there are other options also we can use. Is it?
Yes, these are all the options. We will stick with uh, size is for small, size TB
Hmm.
is for, let's say, experimentation, POCs and all. Along with it, even Chroma DB also is good when you have limited number of documents. You'll have to go and check your limits. VWeight is a big one. I mean, VWeight is not a small one. VWeight is, really very production grade. These are free options. But then if you want, but you'll have to either host them somewhere. Like Faiz and Chroma are hosting is very easy. These are kind of in-memory DBs only, right? VWeight you will have to deploy using a Docker. You'll have to use a Docker to deploy,
Okay.
right? So, but if you do not want to have this overhead, then you can take any of the like you can use AWS or GCP or anything, right? We can use any of these,
Got it. Okay.
right?
Yeah.
As of now, we will, I'll just have one example or few things covered with OpenAI embeddings, you know, but that is again an embedding. I mean, they don't provide the vector DB, right? So we will have one session with VWeight, how to do with VWeight. For VWeight, I'll have to show it on my local system because on Collab I will not be able to show. For Pice and Chroma, I guess we can easily run it on Collab. Chroma, I'll have to check on Collab. Pice I have been running since very long, so we can have all of these things, right? And for VWeight, I'll show it to you once. But again, VWeight is when you have two huge documents, and you want some free alternate in terms of AWS or GCP, then basically you choose VWeight. But VWeight, the accuracy of VWeight is also very good.
Okay.
Right. All right. So we'll just go with
One more actually
yeah,
point, but that's not relevant with this
sure.
session. I will we can discuss after end of this.
Yeah, yeah. If it's okay, you can ask even now also. No issue.
But yeah,
Right.
that's not relevant. But in our company, we have a AI hackathon,
Right.
and actually, I already requested my CloudOps team to provide the AI infrastructure. For
Correct.
example, we are using the Azure AI to store
Correct.
all the document storage for
Correct.
vector
Correct.
database, right? So, but that's very limited to not all of them in the team members.
Correct.
So, in that case,
Correct.
what are the option actually? That's because if I wanted to just any AI agentic like uh, solution, right? So what are the
Correct.
option I can use there as a part of the AI infrastructure? So one of that Ola or something that LLM that can be like it's very difficult to identify very quickly, right? So that topic actually we can definitely discuss
You
whenever
can
you.
use Quen 3 models, right? If you want to use it in the local. I mean, I guess your local. I do not know what if you have 2 to 3 GB of GPU also. Quen will be very efficient. It will run even in local. So you can have this is Quen re-ranker. This is Quen embedding. These are Quen 3 models and Quen 3
But these models are for Word document processing related, right?
text
Text.
LLMs. Yes,
Okay.
right. Like I mean, what did you want?
Uh, yeah, I mean that not specifically the text or Word, but any other solution. For I can give you one example. I
Right.
wanted to develop the AI agent to just I will write the some description. It will create a Jira ticket with a
Correct.
story, and
Right.
after that it can also based on that story it will also create a UX. I mean that through the Vercel, we have a
Right.
license of Vercel, right?
Correct.
So all these things, if I wanted to use in my local, it's very difficult, right? So I have everything. I need to have a license. So this is just one example, actually.
Correct. Right. Right.
In that case, how I can find those things over the internet, actually, which one I do not want to use, and but I can trial purpose. I wanted to start. Then what are the infrastructure I
See,
can
for
use?
basically again, you will yes you will need one cloud or maybe at least some Google Cloud credits because you will have to fine tune the model for at least for generating the UX
Hmm.
because UX generation will require some kind of either using scripting or using HTML or something like that, right? You will have to use something so that the UX designing happens. Now, uh, again, you have to prepare some data set for that, but an initial UX or for the demonstration purpose, I guess you can even connect from ChatGPT also. It can give you basic UX. I mean, not that something fits into your requirements, but yet it can give you a generic UX. And for even generation of Jira tickets and all, you can use the RAG basically, the same thing that we are discussing, so
Right.
that it is able to generate the ticket and description with respect to your previous requirement. So when you say that, with respect to this requirement, I was able to generate this. With respect to this requirement, this is my Jira ticket. So when you then give these kind of instructions, it is able to generate the proper Jira ticket with description. For UX, you will have to use, some tool. I mean, you will have to get the script generated from AI. Or the tougher part is that you will have to get the image generated from AI. But image generation again you will have to fine tune. By default, you will not get that feature.
Right. Right. Okay. Sure. Thanks,
Right.
Anand.
Sure. All right. So, okay. So let's start with the RAG. And again, I will use, as of now, since the whole point being that I wanted to show all of this in the local system only. So we will, use everything in the collab, and that too, I Quen 0.5b will use for a certain time. For most of the simple requirements, this will suffice us. Then when we will go for multimodal thing, then we will jump to more requirements, right? So as of now, I'll just go for installation of pip install. I already have transformers, torch, accelerate, bits and bytes, Q. By the way, next weekend we won't be able to have the classes. Like I will be at the event and it's at Pune. So for the CAI event, mm, I forgot the website. I guess that so this is website, and I am here in the speakers. Yeah, we have some business people coming and uh, speaking here. So I will be speaking on basically. I'll be demonstrating the usage of AI for audits, basically. So next, Saturday and Sunday, I will be involved there itself. So next Saturday, Sunday, maybe I'll share the session. I guess these guys have kept it paid, but I'll try to get the session and I'll share it for you at least. Uh, and anyways, whatever the demo I'll be building, I will be demonstrating it here also, right? Okay, right. And there. All right. So model name that we'll again use this instruct model. The model name is equal to when instruct when 0.5. Accept this model, and then let's first try to load this model, right? Uh, so the same thing that we have been doing till now. First, tokenizer is equal to auto tokenizer. Model name trust remote code. I mean, that's okay. Okay, we'll have to auto tokenizer and all. We'll have to import first. Import dot and from load in 8-bit. Will it load? Let's see. Remote. Okay, tokenizer is here. So I'm not cutting down the model into 8-bit or something. So I'll load into 16-bit so that I do not have very less performance. Although even as of now, the model is very small, so I don't want to reduce its capability. And this model is very small. It might load in 4 to 5 GB, and I'm just running on CPU itself. Very good for learning and playing around. And even if you fine tune it for your use cases, I mean, it can suffice. Next, okay, generation. We can just have a generator thing. This is now same thing that we have, discussed pipeline thing for generating whatever the things, the generator pipeline. Now using generator, we can go ahead and, generate text using some sample prompt. Right. So let's say this is a prompt. I'll make it 400. So I'll say that write a poem about India. This is Chinese model, so if it says anything wrong, so don't be surprised. I should reduce it so that it will speed up the process. It is taking some time. Okay, you see, 0.5 model, a billion model, and India is land of diversity, melting pot of cultures and tradition. From the bustling streets of Mumbai to serene temples of Varanasi, people are built tapestry woven with threads of history, love, and beauty. From the vibrant music of Carnatic and Spandu sweet sizzle of curry and naan bread in every corner. It's not a poem, it's an essay basically, but I mean, not a nonsense thing. I mean, it makes sense, right? It is not that it is not making any sense. I make it 100, it might be fast. Anyway, I'll now go ahead and further I'll have to install the files thing. So I'll first have to install sentence transformer. Now sentence transformer is basically the library that comes, for converting your text into proper text vectors. Again, an open source one, sentence transformer. You can just go to this website and there are some very good models. Embedding models, we want to use embedding models. We'll use this model, all mini LLM L6. And then they have, how to, even if you want to fine tune your model on your custom sentences, you will have to do this if again your use case is very complex. Training overview, quick start installation. Awesome. Training exam sentence transformers, evaluations. Start. There was a table here that was displaying all of the transformers and its accuracy also. This is the benchmark. These are some of the, and all of these have specific, they have been trained using specific way. So depending on how you are going to design your application, you will have to choose these models. These are some of the benchmark scores. Right. Anyways, let's first have basic thing. So we'll just go ahead and first install it. Pip install sentence transformer. And then I'll go for pip install Spice CPU -Q. So my 5 DB is installed now. Right. I have a company of solar panels. I have a company of solar panels at Vadodara, Gujarat. Give me 500 words about it. So this will be my, as of now, source document. Right, plain text about it. Okay, so here it is. And I'll take this as my document. Okay. Now, what is the length of this document? Let's check. 562. So we can basically divide it into small chunks and then we can store it. Right. Now the next is that we'll have to chunk our data, chunk data and store into Spice TV. Right. So let's start with it. So first and foremost thing, chunks will have to split the data, right? Document and splitting, let's say if we do it on length, so we'll start underscore index equal to 0. Start underscore index insertion length of document and underscore index is equal to start underscore index plus whatever the, I'll choose some chunk size so that I can, this is very important so that I can change and check that what is, and then chunk underscore size and then chunk underscore overlap. Chunk underscore overlap is 30. What is this chunk underscore overlap? So it should not be that, let's say I have 60 lines in a document, that first 30 is in document 1 and second 30 is in document 2. It should be, okay, 30 is in document 1, but so that, that junction is not lost. There might be a case that both of these lines, even though you have separated them by full stop, but there might be a chance that they might be containing some information in conjunction to each other. So overlapping, storing the overlap is very important. And this also we can see that what is the overlap as of now. So I'll keep that as the overlap, right? Chunk underscore size, start underscore index and chunk underscore size. And then we'll go for chunk is equal to chunk is equal to document start index. Start index, no, not at all, not this way. Chunk is equal to, this is correct actually. Chunk is equal to document or starter, and start index is equal to end index minus chunk overlap. Now I will have to store all of them somewhere. Chunks dot append the chunk, right? LangChain will do all of this for you by default, don't worry again, but we'll have to cover a few examples of building it from scratch, right? Okay, chunks dot append and chunk done, I guess. Now next is storing the data. So let me store my embedding underscore model is equal to sentence transformer sentence transformer all mini LM6 v2, and I guess we did not import our transformers, right? Let's import them first. From sentence underscore transformer import sentence transformer, and then we have import spice and import numpy as in, got it? sentence underscore transforming.
So Anand, the sentence transformer and the above, right? Whatever you assign that text
Right.
to document, all this and create chunking the logic, all these things using the LangChain framework library.
Yes, LangChain will give all of this too.
Okay.
You just have to choose the
Even,
model.
and importing the files DB, it's a separate, right?
Files is yes. You will either I mean, you just have to specify in LangChain that if you want to use files or you want to use like vwait or you want to use any other uh, you know vector db, so you'll have to specify it there.
Okay.
Right. And my embedding is loaded. Yeah, I mean, for building normally applications it is better to go with LangChain, but at least I'll have to show you that how does it looks like. So maybe tomorrow we will start with all of the examples of LangChain. We'll start all of the LangChain basically from zero, and then we will deviate from LangChain. We'll finish all of the LangChain concept, and then from LangChain we'll go towards agents. Okay, we have this model here. We have not. Alright, okay. Document is here. Now embedding underscore model and document underscore embedding, I guess, is equal to embedding underscore model dot encode chunks, right? Okay, embedding underscore model is equal to sentence transformer. This is what we have done is encoded our data, right? Embedding underscore model done. All of the chunks are encoded. I will have to check, store it into files DB. Dimension, index, and document. Index dot add document embedding. Document embeddings. Okay, done and done. My data has been added to my files database, right? Step number 3, right? Query. We need a query. Okay, step what we have done, we have done the process till this one, right? We have achieved this thing. Okay, so we have done all of. Now next is, after this what we need to do is till this step we have achieved. Next is we need query. So let me first have a look at, although this is a toy example, like I said, but Sun Park Solar, based in Vadodara, Gujarat, specializes in providing high quality solar panel solution. We are dedicated empowering home business and regional sustainable. Our service include consultation, installation, maintenance of solar power, helping clients reduce electricity bill, satisfaction is your trusted partner. Okay, let it be. So I'll say that, where is Sun Park Solar situated? Let's say my query is, where is Sun Park Solar situated? Got it? and then query underscore embedding as natural, right? And then basically how much distance you want to keep, how much vicinity you want to have. So for searching, I will take it as 2. Now first let me do this step by step so that you understand, you can see. Now I'll go for distance, comma, indices, I guess, equal to index dot search query underscore embedding and k, and then tree underscore chunks is equal to, I'll have to just go from the chunk, from indices, chunk of I of I in indices. That's 0. So basically now here is where my, so it says, see, it has, what it has done 2. I can take 3 also. What I can do is I can take 3. It really depends how much you want to take. 3. So now it has given me 3 different. Sun Park Solar based in Vadodara contribute to greener with the utility. Sun Park Solar is trusted for energy needs in Vadodara. So see, I mean location, and it has fetched me 3. I'll take as 2 only. Right? Okay, done. And now I have to give this to my LLM, right? I'll have to combine it to my LLM. So combining it to LLM, now we will have to, earlier what we used to do, we used to give our prompt very directly to, LLMs. But now we will have to learn how to format our prompts. I mean, see, prompting is a great technique, but yes, I mean, we'll have to learn, how to efficiently prompt, because we will be learning various ways of prompting. Just by right prompting you will be able to get your answers, and just by right prompting your AI should be able to discover, I mean, that what is wrong with your answer or what is wrong with your prompt, right? So now you can have a small prompt builder, but you should get used to it, because so this is the first thing from a system, that you are a helpful assistant, right? That you are question answering engine, and let's say answer what has been asked in query only, without any context, right? So I don't want any context, I just want my answer, correct? So this all will convert it into a prompt basically. I'll just show you how. And then role user, and content is query, and we also need context here, right? We need role user, content is, okay, hold on, now format it. So it goes as, context is, what is your context? Your context becomes retrieved chunks, and your query, and then your answer, that this is where you need to give your answer, right? So it becomes query retrieved chunks. Retrieved chunks have to be joined together. It cannot be dot join. So basically this will automatic, or you can join it here also. After this you can have one complete join statement, right? So this expression will join all of the different lists together. Let's say if I do this dot join, done. So what it has done, see, from first to second it has joined everything into one, and this is my query, right? Now, okay, let me now prompt underscore for underscore model is equal to tokenizer dot apply underscore chat template, tokenizer add generate template true, right? Tokenize false, and then let's see what my prompt looks like. So I mean this is optional. This is just for prompt management. You see, I'm start system, your question end, and all of these things. Although you do not understand that when you are prompting with your chat GPT, but from inside it is following a strict format of prompts. That this is where it should end, this is where it should start, and all of those things. So all of those things will be taken care by prompt builder basically, right? And then we have our prompt here. We'll just give with result is equal to generate use generator for generating result. Okay, print generator prompt for model, I guess max B tokens. Okay, result and generated text. Let's check out. Okay, answer: Sun Park Solar is located in Vadodara, Gujarat. Right. Next, I will change my query. Right. What is use of solar panels? Now, see, Quen did not knew about all of these things. What is use of solar panels? This is again just for a small thing. Okay, what it has done again: consult engineer solar helping clients. Sun Power is providing high solar panel solutions. We are dedicated to empowering homes and buses. Now, it did not. No, 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 no. Usage of solar panel or benefit of solar panels. Benefit. We have to be very specific with our queries. This time the context has increased. Since now the context will increase, time will also increase. Okay. This is impressive. It says reduced electricity bills by generating their own power. To environment impact, solar energy is a clean renewable source and all of those things. Energy independence. Now, if you see, this is not from the context. Some of it is from the context that has been given. Sun Park based in Vadodara, specializes in dedicate empowering. Right. Some of it is from the context, but some of it has already fetched from the information it already has, right? So this is a very simple toy example of RAG. There are lot many features, and for discovering those big features, we'll have to make our problem more complex. So what we'll do tomorrow, first and foremost thing, we will start with we'll read a big book, and then we will apply all of this. All of this whole pipeline remains same. It's just we will need to uh, first take out the proper chunkings from the book and store them into our vector databases. And then we will see few more tips and tricks, which will continue. I mean, then we'll start with the LangChain, because with LangChain it is easier. All of these things are easier. LangChain is specialized around these things for remembering the memory, what user asked 3 times earlier. All of those things are present in LangChain, and LangChain makes all of the RAG easier. So we'll go ahead and we'll use LangChain, and along with LangChain only, we will then learn how to use agents and all. So for today, I'll keep the session till here itself. The reason being, I have a small, I mean, thing to accomplish. Right. All right. So any questions, team?